So remember today we're going to be going through the PowerPoint. Did we start filling in these notes last week? We did. Okay, good. All right. So remember the PowerPoint that I'm going to have up follows this. So for instance, there's a blank on my PowerPoint and it's in red right here. And then this is a couple of things. I think did we fill in steps to solving a problem, or does anybody remember if we got that far? Anybody remember? If not.
Yes, we did.
We did. Okay. Thank you, Parker. All right, so I'm going to start back right here, okay? And then here's how it's going to go for the most part. We can kind of review realistically. Here's the hard part about these equations. You look at them, you're just like, holy macaroni, that's a lot of letters, right? But we already know a lot of these letters. Like we know VF, we know VI, we know A, we can figure out D, we can figure out T. So really what we're going to be working on today is making sure that we know those variables and then plugging in. So that's why I was redoing that PowerPoint, so that when we get ready to plug them in, like sometimes you may know the numbers, but remember everyone may not be familiar with PEMDAS, like order of operations. So we're going to talk about how you would type it in your calculator, okay? Because for instance, when you see an exponent, which is like this small number right here, then you have to do an exponent before you multiply. So that's kind of what we're going to be working through today. So hopefully we'll get through these formulas, okay? And then we're going to do practice problems on my PowerPoint, okay? So you can just do them on your notebook paper. And then these problems, okay, so we have, I'm making sure, I believe these are all different than the ones that I have, okay? These problems, there are 8 problems on here, okay? So that's what you're going to be working on for homework. And what we're going to do is eventually, maybe on Thursday, for homework, I'm going to give you a quiz, a homework quiz that's going to ask you the answers to these questions. Okay, so realistically, you already have the questions. Okay, so today we're just practicing. So make sure you have some type of calculator nearby. And then you'll have from tonight, so you'll have Tuesday night, Wednesday night, Thursday night, Friday night, Saturday night, Sunday night, Monday night, to Tuesday night to input your answers from this sheet. Does everybody understand what I'm saying? Okay, so technically your homework are these 8 example problems, but I don't want to see this sheet. You can turn in your sheet, that's fine, but the answers are going to go on a Schoology quiz. Like your Schoology quiz will say, we'll have this problem again, a car moves from 10 meters, blah, 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 blah. Hopefully you will have already worked it out. So on the Schoology quiz, hopefully all you're typing in is your answer, okay? And I maybe we'll even set it up as multiple choice, but I'm not gonna lie to you. One of my options may be none of these, okay? So it doesn't mean that I necessarily put the right answer up. Okay. All right. So if you have this sheet up, if not, you should have an idea. We're going to get ready to go through this PowerPoint. I'm going to put the PowerPoint on this screen. So give me 1 second. At this point, you should have your calculator, something to write with, possibly your Kinematics notes open, and we will hop right into it. So I'm going to go, and I know that we have been through this, okay, but I'm going to go super fast through that PowerPoint again because the more I say it, hopefully, the more it sticks, okay? So that's my goal. I'll say it over and over again. I'll say acceleration is A is acceleration, A is acceleration over and over again if it means eventually it sticks, okay? So we talked about free falling, okay? So we kind of went through this super fast. Let me just turn this so I can make sure I see what I'm doing here. Okay. We talked about base jumping and skydiving and talked about what we call free falling. Okay, so I'm going super fast because we've already done all of this. Free falling, which had to do with the fact that objects that are just dropping or being thrown, what goes up? Anybody know how to finish my statement? What goes up? Somebody finish.
Must come down.
Must come down, okay? And that is because of our friend gravity, okay? And then we watched the cool video with the bowling ball and the feather. And somebody, just in case somebody wasn't here, tell us what happened with the bowling ball and the feather.
The bowling ball fell faster than the feather, but when they took out the air, like what did they take out? The air specifically?
Yes, they did.
They fell at the same rate.
Very nice. So once they took out the air, they took all of the air out of this giant room, which also means no one could be in there, right? They fell at the same rate. There was no air resistance or nothing to keep the feather and bowling ball from falling at different speeds, okay? And the only thing acting on was our friend, again, gravity, okay? So that was the only thing acting on it. All right, then we learned, okay, that gravity has a certain speed and it doesn't change. And that speed was 9.8 meters per second. And sometimes we see it as 9.8. Sometimes it's 9.81. It just depends on like what sheet you're looking at. And then we said we would use a negative sign. Somebody tell me what it meant when we use that negative sign. Does it mean you had a negative speed?
It means you're decreasing.
Did it, in this case, did it mean that you were decreasing though? I remember what. Typically, if you have a negative acceleration, it means you are decreasing acceleration. It means you're slowing down. But we figured out when you were falling, if anything, you were speeding up. So what did the negative sign mean? Does anybody remember? No one remembers?
Did it mean that you were going down?
Correct. It meant that you were going down. So the negative sign was only because of which way you were falling. Okay. So that negative sign was just telling me that the direction of the acceleration was down. Okay. Because again, as we said, what goes up must come down. So even if you are, for instance, if you throw something, okay, it is going to eventually go that way, or even if you shoot it straight up, okay, it is still eventually going to come down, okay? All right, so that's what that means. All right, so then we eventually moved on. I think we got about this far. We start talking about kinematics. So this is when we start filling in our notes, okay? So if you notice here, it says 9.81. All free falling objects will have a constant acceleration going down. You don't throw a baseball off of the side of the building and it goes down for a little bit and eventually goes up. It will always go down. So that's, we do know. And it will always fall at the same, not speed, but acceleration, okay? And if it's an acceleration, that means it is speeding up. It is constantly speeding up. That's what acceleration is, right? Constant speed means I'm walking at the same speed the entire time. Constant acceleration means I'm accelerating, I'm speeding up consistently at the same rate, okay? Can everybody see my screen? Like somebody tell me what they're seeing right now. Are you guys seeing the PowerPoint? I need somebody to, Kaylee, can you see the PowerPoint?
Yeah.
Okay. But you may want to try logging through, what are you on, your phone or your computer?
My computer.
Okay. If you want to pull up the PowerPoint, I'll tell you what slide we're on as we go through it. How about that?
Can I just leave and come back?
Yeah, absolutely. Okay. All right. So we're going to go kind of slow so we don't miss Lydia. But so on your notes, you should have had kinematic equations can only be used when we have constant acceleration, okay? And the only time we have constant acceleration is when, let me let Lydia in. When we have constant acceleration is when all of the when the objects are, oops, when the objects are freely falling, okay? Or if they're a projectile, remember projectile just means it's like this. Like even if you shoot a, like for instance, if you were to shoot a, okay, I am not, listen, do not judge me. I teach science for a reason. Let's just say this was a cannon. Okay, so like here's the little wick and you light the wick. Then, great. Okay, then even if you shoot the ball out, it eventually is going to go down. That's a projectile, okay? That's also, this is a cannon, okay? Cannon or a gun or whatever. All right. And air friction, which is this resistance, is so small that we don't pay attention to it, okay? All right, so now, that was a very, very quick review, okay? Now let's get into our equations, okay? I'm gonna try to color code so you, I think did we go through this equation already? Somebody tell me. Yes, no, maybe so. Can somebody give me a thumbs up if we went through this equation? Okay, I don't see any thumbs up, so we're gonna go through this one. All right, so the hardest thing about kinematic equations is really just remembering your variables and making sure you plug in your numbers correctly, okay? So if I were to color code these, okay, really the big thing to remember is like you see all these letters mixed together, but remember they're really separated. Like, so you have V, oh, sorry. Forgot I had it on mouse there, okay? So for example, okay, you have VI, which we have talked about before. We know that is your initial velocity, okay, or your starting velocity, all right? And then you have T, okay? So if you have a highlighter or something, or you want to draw boxes around it, that would be great. So T is time, so I'll box it. How about that? Here's your T. Here is your VI. Okay, and so what that really means is VI times T, right? That's what that really means, okay? We have D, which is our displacement, okay? That's right here. Then we have half, okay, plus half. What's another way I can write half in the calculator? Does anybody know how to write half in the calculator? How can I type that in?
Don't you just divide by 2?
You can do 1 divided by 2. Anybody know what a half is in decimal form, though? That'd be a lot easier. What is it?
0.5.
0.5. Very nice. So if you want, I think personally, it's a lot easier for us to say 0.5. So this is the same thing as 0.5. Okay. All right. So 0.5. Then you have A. We've talked about A before. That's acceleration. Okay. Which makes sense because acceleration starts with the letter A. And then we have T again, which we have already used. So we get to use T twice in this equation. Here's T. All right. Did I miss VF? Oh, VF is another one. So here's your T, okay? And just like we were talking about order of operations, okay? So for instance, here, that this squared right here, right? And we're gonna do some practice problems. We would have to square that before we did, because this A times T squared, this would be A times t squared, and we would have to do this first, okay? So you might want to make a note. Do this first, okay? All right. On this other side, the only thing that's new, we still have, let's see, we still have VI, and this time VI is squared. We have the number 2. We still have A right here. We have D. All right. And now we also have VF. Let's see what color I have not used. How about purple? Okay, VF is right here. All right. So these are our 2 kinematic equations, okay? And really there's more than that, but these are kind of the 2 that we're gonna focus on, okay? All right, so now let's talk about how we solve kinematic equations. All right, whoops, sorry. Let me go back. I'm gonna save this. Thank you. All right, now I'm gonna clear so I can make sure I put these up. All right, so now, if we're looking at this, when we're solving problems, the first thing we list are our knowns and our unknowns, which we have done time and time again. If we have an equation, we always list out all the variables and we fill in the ones that we have numbers for, and we leave the ones we don't have numbers for blank. So same thing, if I give you an equation, I give you all of that stuff, there's gonna be one thing missing, and I'm gonna give you everything else. All right, so here's the additional step. We have to look at our knowns and our unknowns, okay? And we have to compare that to the formula. So I know, like right now I'm talking and you're like, some of you may be like, what is she talking about? Remember, we're gonna go through some of these equations in just a second, okay? All right, so it says compare knowns and unknowns to formulas, okay? And then we need to match them up. So in other words, okay, for instance, if I gave you an equation and you notice that, for instance, like if I gave you an equation and you notice like there was no BF, right? Oops. Oh my gosh. If you notice there was no losing it, VF, then we probably wouldn't use that equation, all right? So let me go back. Here we go. All right. If we need to draw a diagram, we'll draw a diagram with vectors like, oh, it shot this way to the right or to the north. So we would draw it. We're going to plug in all our variables, not forget our negative, which just means it's going down. We're going to solve for it. All right, here we go. Put on your thinking caps, please. Make sure they are buckled tightly under your chin, okay? Some of this stuff we should already know. If you see something like it starts from rest, or it was dropped, okay? If I drop something, okay, look at me for a second. If I were to drop my phone right now, okay, right now, what is the initial velocity of my phone? How fast is it moving? It's at rest. Is it moving at all?
No.
No, it's not moving. So if I'm dropping something, I first have to hold it still, right? I mean, even if I chuck it, it's not moving at all because it's in my hand, and then I let it go, okay? So I either let it go this way or I let it go this way, but initially it's 0. So if I drop something or it starts at rest, it's 0, okay? When it stops, it is no longer moving. Once I throw this, and if it lands on my desk, it is now, let's land somewhere where you can see. You can see here. It is now no longer moving, okay? So that means it is at rest. Okay, so let's go back to the PowerPoint. All right, so when it comes to a stop, that's also a sign. So in other words, if you feel like you're missing a number, you're like, they didn't give me an initial velocity. They didn't give me a final velocity. Go back and check. Did they say it started at rest? Did they say it stopped? If you see starts at rest, dropped, or stopped, then you should know that you actually have a number even though I didn't write it, okay? if anything is falling or thrown through the air, we always know acceleration. It's the negative 9.8 because that's how fast gravity is always going to accelerate. Okay. All right. Here we go. Here is a equation. We've already gone through this. We've talked about those variables. You have a D for displacement, VI is initial velocity, T for time, and A for acceleration. Okay. In this formula, you do not have, that says, that should say, sorry, I need to change that. This should say, in this formula, you do not have a final velocity. Okay. I'll go back and change that on my PowerPoint. All right, so on this one, you do not have a final velocity. I'm going to change that right now because if I don't, I'm going to forget. All right, so that should say final. Okay, so now if I go to this one, okay, this one, you have VF, VI, A, and D. This one, you do not have time, okay? So if I give you an equation and you see time in there, this one doesn't even have time in it. You probably cannot use this equation, okay? All right, so, oh, look, these are your questions. I think they are, at least maybe one of them, okay? So let's look at this. A car, get ready because to participate because I may call on you, okay? A car, okay, a car from stop accelerates at a rate of 5.8 meters per second in 10 seconds. How far did it travel while speeding up? Okay, so first thing, anybody want to tell me what's the first thing that they see that's easy for them to pick out? Okay, I'll call on someone. No worries. Let's see. Stephanie, what do you see? Tell me anything that you are reading in that statement. A car from stop accelerates at a rate of 5.8 meters per second in 10 seconds. How far did it travel while speeding up? Thinking about all those letters we had before, is there anything that you say, I'm pretty sure that this represents whatever, VI, VF, A, D, T, whatever. Let's see. And it is a lot easier if you guys will just unmute because I have to try to check the chat. All right, Stephanie, you got something for me? What you got for me, Stephanie? Okay.
Can you repeat the question again?
Yes. Okay. So in this statement, it says a car from stop accelerates at a rate of 5.8 meters per second squared in 10 seconds. How far did it travel while speeding up? Could you look at any of that and tell me like, oh, I think that this is like VI or F or VF or T or A or whatever, or D? Anything that you see? So in other words, if I were to write down all the variables that I just happen to know, like I know there's, and it may not be in this equation, right? Or it may not be in this problem, but I know there's a such thing as a VI. I know there's a such thing as a VF. There's a such thing as A, there's such thing as D, and there's such thing as T. If you looked at all of these, Stephanie, could you tell me if you think you knew any of those?
I know the T will be 10 seconds.
Very nice. Excellent. So that's all I'm asking. So I look at this. Stephanie said that T is 10 seconds. Very nice. So we know that this is T. All right. And then Jalen, you were telling me something in the chat. What were you telling me? And Robin told me the same thing.
VI the initial velocity is at 0.
Very nice. How'd you know that it was 0?
Because it says the car from stop.
Very nice. A car from stop. Very nice. This is VI. So we know VI is equal to 0 meters. Very nice. Anybody else see anything else they think they know? Or what they're looking for. Sorry, go ahead.
Acceleration is 5.8.
Very nice, Parker. All right, so it says accelerates at a rate of 5.8 meters per second. We also know that this is always the unit for acceleration. So this is A. So this is 5.8 meters per second squared. Okay. All right. And then what are they looking for? So for one of these is going to be missing because we got to figure out which equation we're going to use. But what are they looking for? Are they looking for VF or are they looking for D?
D.
They are looking for D. How far did it travel? Not how fast was it going later on, right? So VF isn't even in here. We don't even, I was just putting this just to see if we were going to use that. So we don't even have that. They're looking for D. This is what they're asking about, okay? So now when I look at this, I've listed my knowns and my unknowns. I have a VI, I have an A, I'm looking for D, and I have a T, okay? So now we would technically go back and compare this to our equations, okay? So I'm going to go back just for a second, and we need to find which equation, okay? We need to find which equation has, excuse me one second. Which equation has all that stuff. So if we go to this next one, let me clear here. Okay. We filled in, we found out VI was equal to 0, A was equal to 5.8, T was equal to 10 seconds, and we're looking for D. Now, looking at these two equations at the bottom, okay, looking at the two equations at the bottom, take about 10 seconds, figure out which equation you think we should be using. Here's your hint. You can't use an equation that has something that you don't need, okay? Reagan, if I were to say that this was equation A and this was equation B, which one do you think we should use?
A.
A, very good. We can't use B. There's not even a VF in there. There's no VF. We don't need it, okay? So we're gonna use A, all right? So now, let's see how that will look, and we'll probably finish up with this problem, all right? So if we were looking at this, now we would go in and we would plug in all of our stuff, okay? So if you needed to draw a diagram, you would. We don't, okay? But if I look at D, luckily I'm looking for D, and luckily it's already on the left side by itself, okay? So remember, you guys had already told me VI, oops, sorry. Where am I? Come on. There we go. All right. So you guys had already told me, remember you told me VI was equal to 0. You said we didn't know D. You said A was equal to 5.8. And you said, what am I missing? T. T was equal to 10. So now all we're going to do is plug in those numbers, right? All right. So here's my equation. Here's VI. Here's VI. Plug it in. Very nice. Okay. Here is T. T is 10 seconds. T, plug that in. 0 times 10 is 0. Great. All right. So remember, I told you that instead of using 1/2, you can use 0.5. That's way easier. Okay. So I'm going to put a 0.5 there. All right. And then my A is next in my equation. So I'm going to plug that in right here. And then my t again, I need my t again because t is right here in the equation. So I'm going to take my t and plug it in right here again. All right. Order of operations, okay? Order of operations, you always have to do exponents first. Remember, it was like, please excuse my dear Aunt Sally, okay? And this was parentheses first. This was exponents, which are those little numbers. This is the order you have to do math if they're all like bunched together. Then multiply, then divide, then add, then subtract, all right? So I have to do this exponent first, okay? So the first thing I have to look at is 10 squared is equal to 100. Okay, 0 times anything is 0. So now I have 0 plus 0.5 times 5.8 times 100, because I already did this 10 squared, okay? So if I do 0.5 times 5.8 times 100, I get 290, okay? 0 plus 290 is equal to 290. We just solved that problem. All right, I need you to be very honest with me right now. If you understand this, I need you to give me a thumbs up, okay? If you are completely lost, then give me a hand clap if you're completely lost. I've only seen 2 emoticons, so I need to know, because I need to know if I should go faster or slower or what.
Can you repeat the question?
If this makes sense to you, give me a thumbs up, okay? If you don't know what's going on, if you're like, I have no idea what she just did, then I need you can give me a hand clap in the emojis, okay? Okay. All right, I just need to know how to go. Very nice, okay. All right, so if you, all right, so we got like 3 minutes. So let me just talk about this one more time. Parentheses, okay? You need parentheses are only if you are putting stuff in the calculator if you want to put it in all at once, okay? So let me see. Okay, so I guess that some people are saying it kind of makes sense. So this is what I want you to try and do, okay? We're not done with the PowerPoint. I want to make sure we go through all these practice problems together. So this is what I want you to do. I want you to try to rework this problem. I want you to make sure you can get 290, okay? So I want you to try that, okay? If you are still struggling, I'm going to repost this. I recorded this, so I'm going to post this video so you can watch it again. And then I want you to try just, I'll put one problem similar to this. I'll send it over Remind and post it in Schoology. And I want you to try it. And I'm going to tell you what the answer is so you can see if you got it, okay? So I know this takes time, and that's why I'm trying to go really slow. But I just need you guys to make sure you tell me if it doesn't make sense, because if not, and I keep going because I think everyone understands, then you're going to be really, really lost. Okay, does everybody understand that? So I know, like, you know, we're not the most talkative on Zoom, but if you were lost, you have to tell me, okay? So I saw one person told me that they're lost. So, and if I get one person, then that lets me know there's probably at least 3, okay? So, let's see. Yes, so that's what I'm going to do. So I want you to rewatch this video. You can skip all the way to the math part. I'm going to give you another problem similar to this on Schoology, and I'll post it in Remind. I want you to try to work through it. And that's all your homework is now. Don't worry about the rest of the problems. We'll work on those on Thursday, okay? Any questions? Okay, I'm